Okay, welcome to part 3 of your Intro to Probability. In this part, we're going to talk about relative frequency. Now, this is going to seem very similar to what we've been talking about, but just a little different because now we're talking about when we're looking at observations, experiments, and so forth. When we want to try find the relative frequency, what happens is you're going to repeat or observe a process many times and count the number of times the event of interest occurs. Then you estimate the probability of that event by looking at the number of times A occurred divided by the total number of observations. So we're going to jump into an example. I just always find that that's easier. Number 1. So geological records indicate that a river has crested above a particular high flood level 4 times in the past 2,000 years. Using the entire frequency method, what is the probability that the river will crest above this flood next year? So we want the probability, right? I'll just put crest. We're going to make this short. There we go. Well, we're going to take how many times it occurred right here. It occurred 4 times in the past how many years? 2,000. That means your probability is going to be 4 out of 2,000. Now, we can reduce that, or let's do a decimal so we can do a percentage with this one. So we're going to take 4 divided by the 2,000, which gives us 0.002. Now, as a percent, remember you're multiplying that by 100. That means you have a 0.2% chance that the river will crest above this flood level. That's relative frequency. That's it. So you just find out how many times something's been observed over how many observations has been made. So there are 3 approaches to probability. Theoretical probability, which is based on the assumption that all outcomes are equally likely. It is calculated by dividing the number of ways an event can occur by the total number of possible outcomes. Relative frequency probability is based on observations or experiments. It's the relative frequency of the event of interest. Then you have subjective probability, which we haven't really discussed, but now we're going to bring it up. It is an estimate based on an experience or an intuition or maybe an opinion. Okay, so not so hard with the numbers. Let's look at example. Identify the method. So I'm going to give you 3 possible scenarios and then decide which is theoretical, relative frequency, or subjective. So A, the probability of rolling 2 6s on 2 6-sided dice is less than the probability of drawing an ace from a deck of cards. Now, we're not doing any calculations. They're actually giving it to us. What we need to decide is what type of probability this is. Now, this is about dice, right? We're looking at dice and a deck of cards. Those are known. We know how many outcomes we can get from a die. We know how many cards there are on a deck and our outcomes for that. That would be what we call then theoretical. Next one. I think there's a 99% chance that I'll pass this math test. That's an opinion, right? I think. So that would be what we call subjective. And then we have the last one. Historical records indicate that an earthquake of this size happens only once every 100 years in this region. So this is based on observations. This one would be what we call relative frequency. All right, so I just want to kind of give you an idea of the different ways that you can use probability, but also what are the different probabilities? Theoretical, relative frequency, and subjective is what we've talked about so far. Now, I do want to end with one more topic, which is the probability of an event not occurring. If you know what the probability of A is, the probability of the event, then the probability of it not occurring, we would just say the probability, and I'll just show you right here. We just say the probability of not A. Because an event either does or doesn't occur, the sum of the probabilities is always going to be 1, right? 100%. For example, if the probability of rain is 30%, the probability of not rain would be 70%. It's what's left over out of the 100. So how we do not A is you can just subtract it from 1. Or if you're looking at percents, it'd be out of the 100%. That's it. You just subtract it by the opposite. So kind of let me show you an example here. If the rain is 60%, if the chance of rain is 60%, what is the chance of it not raining? The probability of no rain, and this is where you do have the 100%. There's two ways you can do this. We know that out of a percent, it's always out of 100, right? Probability is always out of 100%. We could just subtract our percents. And that means the probability of it not raining is 40%. If you're going to do it as a decimal, you would take 1 minus 0.60 or 0.6, and that would give you 0.4 or 0.40. It's the same thing. Either way, either as a percent or as a decimal, but you just found what the probability of it not being no rain. Example 2. If the probability of rolling a 5 on a die is 1 out of 6, what is the probability of not rolling a 5? So I'll just put no 5. Well, we know the probability then is going to be 1 minus 1 out of 6. Oh, this is where you're going to have to change that 1 into a fraction. As a reminder, a whole, this is a 1 whole. Look at the denominator here. Your denominator is 6. That means 1 whole will be 6 out of 6, and then minus 1 out of 6. That's going to give me 6 minus 1, which is 5. And then remember, we don't change the denominator, so that stays as 6. So your probability of not rolling a 5 is going to be 5 out of 6. All right, well, that ends our entire first section of probability. Lots of information.